Hi, everyone. Welcome to the September 15th SIG Apps meeting. And we have a few topics today. The first one is from Eric. Proposal for a generic workload for scheduling.
Thanks, Janet. If the host wants to allow screen sharing, I could show some slides.
Yeah, I just gave you access.
Okay, so in SIG scheduling, we've been talking about how to solve gang scheduling, and we realized that it's likely to lead into a lot of other things. And so we moved from modeling just a group of pods, like a pod group that represents somebody to be gang scheduled, into modeling entire workloads. That fits in better with where we think we'll need to go topology aware scheduling. So we're now looking at introducing a new core resource. We're tentatively calling that scheduling API group, and then the kind would be workload. And so to make this work, we do have to add a spec.workload field to pod, which is an object reference. So either the user, so when stateful set makes a pod, for example, the pod template will include this spec.workload field, or the controller will populate it automatically. And so all the pods that are made by one workload controller are going to have the object reference back to this abstract workload object that contains information the scheduler needs. So starting from like most concrete and immediate in number 1, and then going down more visiony towards 7, we know we want to do gang scheduling and kube scheduler. There's currently 5 different out of core gang scheduling implementations. We can see that some workload controllers like Kubeflow, Train Job, they're having to like include support in the workload spec for multiple different types of gang scheduling implementations. This is a really strong signal to us in SIG scheduling that like this should be solved in core. Doesn't mean it's the only way to do it, but it should be offered as a feature in core. And gang scheduling here just means like all or nothing, I guess, binding of, or at least allocation of potential binding of pods within a workload. It doesn't mean like switching between things. Then we think a follow-up for that pretty quickly would be to add some topology aware scheduling service capabilities in Kube Scheduler. And so that's going to involve like having policies inside this workload object. And then we've kind of got some ideas of where to go after that. So like, why are we introducing a new type? Why do we not directly watch like job and job set and all the workloads? This is what Q and Volcano do. But in Kube Scheduler, since it's in core, we kind of don't want to take out of core dependencies, and we don't want to privilege certain, workloads that are friends of Kubernetes versus like private or less well-known job extensions. We try to create a mechanism that makes it easy for anyone to leverage the power of this workload resource, or like tell the scheduler about their workload without having to write in core code. And I'm not sure why I have that. Why not, with nothing following it there? And so like, why is it a core type instead of a CRD? The Kube scheduler needs to watch it, and there's really no infrastructure in there to watch CRDs. And my knowledge might be out of date, but I don't think we have infrastructure to automatically load support for CRDs from a stock Kubernetes distribution. Please correct me if I'm wrong there. We want this type to be available at the outset. So thinking about like this from the perspective of like workload controllers and users creating applications, like what are the life cycles? So we came up with like 4 different types of life cycles. Manifest would be like you create a stateful set in your manifest and you have other assets. So you're adding one more asset, which is this workload asset, and they just share the same life cycle of this manifest. The good thing about that is that it doesn't require orchestration by workload controllers. We want that to be possible so that people have flexibility, but we think most people will use these latter three options. So the next option is adoption. That would be where the user could create a workload that describes the precise behavior and like scheduling needs for their job. And the job controller would see it and adopt it. And then when the job does GC, and there's a bunch of different ways that job can do garbage collection, it would also clean up the workload at the end. So that way it shares kind of the same life cycle as a job. Defaulted, we think that something like index job could make a workload resource that like specifies gang scheduling information, like just using reasonable defaults. When you start to get into like topology information, we probably need to add fields eventually to workload controllers, or at least annotations or something, so that they can take the request in the true workload object and then stick it in this scheduler used workload object. We call that last flow like templated, and that might not be the right word for it. We already started to see this pattern happening in some workloads like MPI job and PyTorch job, where they have a place for basically scheduling information. Right now, they're passing it to things like co-scheduling plugin or Q or Volcano. We want that path to be more well-defined and work with KubeScheduler. So far, a lot of discussion's been in SIG scheduling. Our intention is to alpha this in 135, and now we're kind of like, okay, we're stable enough. We can start talking to other SIGs, and SIG Apps is clearly want your feedback on where we're going. We've had a lot of discussion in SIG scheduling, and we started out under this cap that's in SIG scheduling kind of 4671, but now the scope's increased. We want to make sure to include more SIGs in the discussion. So if you're interested, you can follow up, and I'll paste this in the chat, the link to the doc we're discussing it on. And so, yeah, this is kind of like why we're here. Hey, we're adding a field to pod. We're adding a new core type. We're going to need to change workload controllers, core controllers, we think, to support this, and advocate for, suggest that custom workload controllers also make changes. Our thought is that we would start a new KEP owned by SIG Apps to cover the work to change core controllers, but we're totally open to feedback on how to do that. And that's it.
Thanks. One question, is the workload object immutable, or can users update that? And when it's updated, how does it affect jobs or stateful sets?
My thought is that as the scheduler's capability to handle updates changes, it will gain updatability. Everything will be optional, but initial validation will really not let you change anything after creation. We will slowly relax it as we like figure out how to do updates. Kind of like pod has evolved to like have more updatable fields over time.
And what happens if the job or stateful set specifies a workload that doesn't exist yet?
If you can make a workload, okay, you're asking, what if the stateful set has a pod template that refers to a workload object? Then that tells the sketch. So if it hasn't made any pods yet, nothing happens. When a pod is made, those pods will block in like a very early stage of the scheduler until they see their workload. When they have spec'd out workload, they are not actionable until a workload appears. And we could probably add status like waiting for a workload to appear. It's been 5 minutes, but because there's no there's like not coherence between two different workload kinds, we have to wait because we don't know if it's coming or not.
I see. Thanks. Any other questions from
So yeah, this doesn't
folks?
actually look like it would be hugely impactful to the way that pod creation is done inside of the built-in controllers, because basically you would just have another workload field potentially inside of the pod template spec. And then when we go to create the pod, it'll reference a workload object. Like you said, in the event that the workload object doesn't exist, it's effectively unschedulable. So you would just like fail to schedule, and then probably in the conditions for the workload objects, we would report back during the like can't schedule or whatever. You would get the not so great telemetry that you get out of the scheduler right now to figure out why that the pod can't schedule, but that's a kind of a broader thing.
It'd be like asking for a node selector that's unsatisfiable. Like,
Exactly.
there's some things we don't help users with that much.
Exactly. That's what I'm saying. Like, and that's just not wonderful today, but it is what it is, right? But I guess what are the other impacts for the actual controller design for workload controllers that you would anticipate based on on adding this feature?
So for like, I did kind of a deep dive on job set, leader worker set, stateful set, MPI job, various modes of stateful set, various modes of index job, a little bit on deployment. And so I think that I have a pretty clear idea how to map all the usage patterns of those to this. It's possible there are some workloads they're not easily described. So if you think about like an Airflow worker or maybe like Argo deploy, like where the DAG is stored, it's like there's a DAG, like we can't represent that information. We would just have to represent it as like, we can have a very highly unspecified workload that's like, hey, I'm making some pods, I'll let you know later what they are. So, but for workloads where you can know like deterministically before any pods get created, what pod shapes are going to be made, we want to have the ability to fully specify that. So problem one is that like some workload controllers will not be able to express their future state well because we can't model it, but we think we did a good job. And then we think we try to do it so there's gradual adoption. So like in the future, there'll be a way to specify like a pod template, we like kind of pod set in Q, or like you say what the like resource requirements are for pods. And if you have 10 different pod shapes and a complex workload, like a bunch of rolling updates, you could update this object eventually to say like, these are all the pod shapes I have. And then the scheduler will be able to do cooler things in the future, but that would be optional. So if you want to be vague about what your pod shape is, you're also free to do that. So I think the impact for any given workload is low. It's only as much specificity as they want to give to get future scheduler features. The baseline, like we'll just schedule pods for you that works today, is never changing.
Philip.
Hey, I read briefly through your proposal, and I saw that you are also looking into like a descheduling or pod termination. For example, when the conditions for the gang scheduling or the scheduling conditions change. Do you plan to like tackle this in the alpha, or like what is your like plan to do in the future, and how do you think it will impact the workload controllers we have in Cube?
Dominic, do you want to say anything about Alpha Scope, or do you want me to take that?
You can complete me, but I think in alpha we don't expect to change anything in pod scheduling in that matter. So we will just start with scheduling ability to schedule and bind atomically. Well, not atomically, all or nothing, but not touch the rest of the life cycle yet.
So looking further ahead, we can see that like, so thinking about like AI workloads, you can see like a classic PyTorch workload would probably not always recognize when the peers are, it might be disorganized when one of the machines fails and the peers like time out talking to each other. And then the controller kind of has to figure out how to reassemble things, and it's messy. So maybe the scheduler could help in that case. Another case, you see people using like Torch, Elastic, and Torch FT, and those are ones where you could like initially schedule a gang and have a full complement, but then it's actually could tolerate the loss of some pods, a limited number of indices or ranks during runtime over like a long running training job. And we want the scheduler to know, okay, it's okay to lose a couple and the workload can still be healthy. We think we probably need to like work with training and like AI specific workloads to find out how scheduler and workloads should work together, like when there's hardware failure cases. But I would say we haven't worked out all the details. Is that at all related to your question? Or is that
Yeah.
too much?
Yes. Yeah. I think I get the gist of that. So, yeah. So as you said, like it depends a lot on the workload. So like to understand like if you can terminate the pods, for example, in the stateful set case, you might have some stateful sets which you could terminate the pods, and there is, for example, like also the question about the revisions in the stateful set, like if you like which revision. So it's a lot of workload dependent. So I guess one thing to consider would be like if we know we might introduce these features in the future, is if it makes sense to introduce like some like validations first, for example, for the stateful set, regarding like if it should be part of the workload or not. But yeah, that's just like on the
Yeah.
side question.
Like for example, stateful set today, you have in order startup or you have parallel startup. Parallel startup is compatible with gang scheduling because the scheduler is going to wait for the required number of pods. But like in order scheduling is not compatible with gang scheduling, really, at least as we imagine, because there's one pod has to like start before the next one can be created. Scheduler can't gang those up. So like that's an example of where the controller could look at its spec and decide, help the user either validate or generate a workload that is compatible with its understanding of what the scheduler can do. So eventually we get in this loop where as you add new features to controllers and you add new features to scheduler, they need to update their mapping from the true workload spec to like what is the valid or workload spec that can be used with it. We thought about that from generation. We hadn't thought about like at runtime user creating a workload and the controller for that validating it. That's not, we hadn't gone that far.
One more thing I can add is that as a part of, in general, workload aware scheduling, we want to introduce a concept of rescheduling. So that would be rescheduling something which already works or is during the binding. So in case, for instance, a workload does not bind completely in terms of gang requirements, we may take some actions like rescheduling, which may in results even bring down the pods that were already started. And yeah, currently we cannot recreate pods, but that I think this is under consideration for the future, how to handle recreation of pods.
We have a couple of different safety guardrails in various controllers, which help ensure that a particular workload is progressing. I don't know, for example, progress deadline seconds or something like that. Are you planning to prepare a thorough document or something explaining users how the workload, the scheduling workload, will affect all of those features? I can't think of anything other than progress deadline seconds or max and available currently, but maybe there's a couple of more which will potentially, if, for example, the workload hasn't been created and we have a progress deadline seconds, and so suddenly we cannot roll out a newer version of a deployment because we're stuck. The rollout will eventually fail. I believe we should be able to list at least those cases where those two should be carefully managed rather than users. I'm pretty sure that they will go return to us with complaints about the workloads isn't compatible with this particular feature or that particular feature, and whether the workload should, or we should basically just describe or warn about potential dangers between in interaction between those two.
You're muted, Eric.
So I think that currently, like once the pod is bound, scheduler is like hands off. And then there's a bunch of variation, like how long it takes kubelet to start it. And then there's also additional variation in how long the application, the containers take to actually get to the state. And any stuff, lots of stuff could go wrong in all those places. We're not planning to change the fact that applications could get stuck like at any point in their kind of that life cycle. And so they still need progress deadlines. And we hope that we're not gonna, what we might do is hinder overall progress if you're doing gang scheduling and it takes a long time to find a feasible place to start. I think that kind of already is a problem today. So I don't, but yes, we should document that.
And I think we will focus mainly on scheduling. So we may have additional like scheduling timeouts or binding timeouts, but once the pods are bound, I think it's up to the app side to track the progress.
Kenneth?
Did we consider doing something like an alloc or a resource reservation as opposed to a scheduling primitive that co-schedules pods? Like, why not have a primitive where we can just say, I want to allocate X amount of resources spread across some topology domain, and then that gets reserved. Then let the underlying controller fill the allocation.
Yes, we spent months arguing whether to do that or this first.
Okay.
And we ended up after doing this one first, and we want to do that one second, I think would be the answer. You end up, if you try to, so we call that a reservation. If you want to, and it corresponds to an alloc basically. The alloc, the reservation instance thing is tricky because it's hard to rename pods. So there's more work to be done to make that work. But the specification, and Dominic, feel free to jump in here if you don't agree with this, but the reservation specification with like the topology requirements, it might have to have multi-level topology like you have, like that is going to look so much like workload that you might as well start with like workload. And then, but we do want to follow up with allocs, like you said. I don't have a timeline for that.
I guess, but that's the challenge, right? Because if you like, let's say if that's your end goal, right? Your end goal is to have something like a reservation, which Miso's had reservations, Borg has Alex, right? So then if we do it this way, where we have all of the controllers communicate with the scheduler to get that direct kind of gang scheduling primitive, and then we pivot and go the other direction, I think there'd be a substantial amount of like, I don't know if you can go that way after we go this way, or can you? You're muted, Boot.
So I would say that to talk in Borg language, like Kubernetes doesn't have jobs yet in the sense, not would have a job resource, but like the scheduler does not look at all pods of a collection concurrently. And so that is the most pressing problem that we have that we should solve. We should get it like all the pods can be intermixed from different controllers in the queue. And the scheduler today is like, I don't know which pods for what. That's like that's what we're really trying to attack first, is the ability to kind of group the pods as they come in by what collection they're in. Then, so that would be a prerequisite for allocs as well. We think that some workloads will, or some true workloads, right? SIG apps workloads will use this abstract workload. Some won't. That'll persist forever. And then when we have reservations, some workloads will use reservations and some will not. So that's kind of how, does that make sense?
It does. It's like, okay, so you're not saying that we have to adopt this, for instance, for stateful set right now. Like for alpha, we could just say stateful set will ignore this, or we will look at it and not allow it unless you use pod management policy parallel, stuff like that. Like we're not necessarily saying, I have another question about deployment, but we're not necessarily saying we're going to adopt this immediately for deployments, right? But like for the workloads where it makes sense, like job, like
I have line of sight to doing cool things for deployment, but alpha is not, alpha is not about making deployments have these workloads yet.
Yeah, I guess the two cases that I see that are in front of me right now, where I think it's like gang scheduling is super useful in the context of the ecosystem we're in. So scheduling like large batch training jobs where you need a certain amount of allocation or you don't run it at all, right? So you can think of machine learning training. And then the other one being, which isn't addressed, multi-instance serving. So like I have a particular topology that I need for these two machines in order to do multi-instance inference serving, and I need to deploy this workload across there, which I would think would map to deployment.
We map that to leader worker set. So like
Okay.
deployment, we think of as a replicated thing with rollouts where one replica is one pod, and leader worker set is evolving to this thing that's like that, except one replica is a collection of pods.
Okay, then what's the use case for stateful set for this?
Stateful people have sort of quote misused stateful set for we just see a high usage of it among our customers for AI workloads, and they just kind of contort stateful set to be able to run them. I'm not saying it's the best case, but like there's a lot of usage, so we want it to work.
Okay, maybe yeah, I guess that's the one hesitancy that I have is like I think the potentially the confusion and interactions with stateful set, but if people are already beating it up today, maybe there's nothing better, right? Like I just need persistent disk for what I get it.
I'm fine with like not touching stateful set and just saying like our alpha goal is for index job to be able to like be gang scheduled. Like that seems pretty unobjectionable.
Yeah, that's pretty unobjectionable, right? And like if the thing is like eventually this is a path along the way to a place where we do something like reservations or Alex, then like don't want to block progress either.
So I think one comment about reservations at the beginning, we'll look into them as a way to also allocate atomically resources for a workload, so that once a workload is scheduled, we have some guarantees that it will bound to the place it was scheduled to, because the binding takes time. It is a long-lasting process. So that's one of the main areas we are looking at the beginning when thinking about reservations, but of course, longer term reservations, that's also in the radar.
Yeah, we think of like a workload with gang scheduling covers a lot of cases, but doesn't cover all of them. Reservation will cover even more. Like, let's say you want to run like between 3 and 5 RAID jobs or something, and you want to set aside some resources for them, and they're backed by RAID programs, so the number of pods they need is like potentially variable. A reservation would be we're not going to model that with workload very well, but a reservation would be a great way to like say set aside a block of resources in some topology for me to like run a bunch of RAID programs or something like that.
I'll just throw there. If I remember correctly, I'm not super familiar with Q, but Q has the ability to define some sort of reservation. Although basically, if I remember correctly, they are calling this Q, so you can put together a handful of resources together and wait in a queue until the available resources, until the requested resources are available, and then it will in bulk create them. Although it's not happening at the scheduler level, but rather at the job level, because Q did not have that particular ability to control the scheduler, if I remember correctly. I might be wrong, and I don't see.
Yeah, so
here.
Q works in 2 different ways. In one mode, it simulates what the scheduler is going to do, and then it like suspends the workloads, and then it simulates what they're going to do. When it's pretty sure the workload has enough capacity to start, then it unblocks it, and it doesn't unblock anything else. And so it's pretty much right about what's going to happen. Use that for CPU. When you do topology where scheduling in queue, it actually sets every pod with a node selector that selects only one node. And so that it's basically telling the scheduler exactly what to do. And Q uses this resource. It's called Q workload, which is kind of the proof of concept. Is like, yeah, this is a good thing. So this is not exactly going to replace Q workload, but it's definitely, I would say, inspired by, and we have confidence that our design is useful by mirroring a lot of what they did in Q workload. We definitely want Q to be able to layer on top of this. I don't know for sure what the project will do, but we want them to have the option to stop simulating, to stop taking over the topology aware scheduling and delegate to Kube Scheduler eventually. It's kind of a matter of time and preference whether or not that actually happens.
And additionally, reservation should allow to reserve more resources than a workload actually currently needs. that's another.
I mean, so like, yeah, I think the two main cases, two good cases for reservation on top of workload is either I have a bunch of different randomly shaped workloads that I want to run concurrently, and it's too complex to express those with one workload object, or I want to like run a array of jobs or something through without paying the setup like in scheduling costs as much. Then you'd be able to like set up and tear down on those pre-reserved resources with high throughput. That's the vision at least. This is like, but this reservation stuff is like not like we still need to go through alpha, beta, GA with just even gang scheduling before we think we can get very far on reservation. Kenneth?
That's a legacy hand up. I am trying to, so are we using the same topology constraints? Like, are the topology constraints just topology spread constraints?
Topology spread constraint is something we've talked about adding, but it's not kind of the second thing we want to do. What we want, so there's two kinds of topology. If you look at Volcano and Q, they use labels. So you have a hierarchy of labels like, you know, rack, like group of racks, whatever. On Google Cloud, we call it subblock and block. But people define that like hierarchy of labels on machines however they want. And then you say like, I prefer to be all these pods from this workload on one rack, but I don't care which rack. So that's like the typical way you do it. Then there's a separate discussion we're having with WG device management. Like DRA can also express this like kind of hierarchy using a multi-node resource, but it can also bring configuration, like runtime configuration when you allocate a rack for use partially or entirely by this, like you now go program a load balancer to like route traffic there or whatever. So we think we want to support both label-based and DRA-based topologies. But essentially they're like, there's some entity that's a group of nodes, and then I want this group of pods to prefer or definitely be on one of those entities.
Right. So like if I need to get everything on the same network spine because I'm using InfiniBand, like I can use a topology spread constraint that says do not deploy in order to make sure that I get my workloads scheduled on that same network spine, like co-schedule. If I'm looking to do something like that's more unique to an individual machine, you probably use something like kubelet resources, like what Amazon does with EFA, for instance. Just make the underlying EFA adapter a resource that you can request during scheduling. So, and then is that how you guys think about
I've never heard of EFA. I'm curious.
It's Elastic Fabric Adapter. It's their version of InfiniBand, but it's like it implements the MPI interface, but the underlying implementation requires a proprietary network driver inside of Nickel, so it's probably not actually InfiniBand. But it's different from what happens on Azure, or for instance, where you just have to take over the whole network, and like you actually are just using raw InfiniBand from an NVIDIA reference architecture, and there's nothing inside of the scheduler to make you aware of like what you've got, right? So like I'm just thinking like which direction do those resources evolve in? Like, so if we think that the right solution is like for adapters, and the same thing is for GPUs, right? You make them as like allocatable resources, and you can get the scheduler can get you to the resources you need. And then the only thing you really have to worry about is kind of the constraints for where you end up landing to make sure that you're not too distant apart from a network perspective. I mean, that's
Let's say InfiniBand is like restricted to one rack, and each rack is capable of having InfiniBand, but like your Cloudflare doesn't provide like rack to rack InfiniBand connections or something like that. So then
performance degrades to the point where it's not usable for large scale training, right?
Yeah,
so like,
so you could either say, I want using labels, pick me at one rack, and then I will like manually set up InfiniBand, or the preferred path is to use DRA. You write a DRA driver whose job is both to represent racks, and when you get bound to that rack, to like find all the pods and set up InfiniBand for you in the driver. It's not super hard to do the former, And I'm guessing there'll be enough examples that people will design for every cloud or can tweak for the second part.
Right, but
But we're splitting. We have a clear line of responsibility with the DRA group folks, I'd say, but I don't know how it works.
and it doesn't seem like the API is confusing or like the domains aren't addressed. So like we have this big gap where we get this out there and then it's like, well, how do I do this? And the answer is, well, you can't. Right. So like that seems reasonable to me.
So I think in the constraints that you could express in the array should be taken into consideration when for gang scheduling. So you should be able to model those implicit topology domains as well. Not necessarily just rack level, but the custom ones.
Yeah, in the alpha, you'd be able to ask for gang scheduling, and you'd be able to ask for a DRA resource, which could be multi-node, and it might work. Is how I would describe it. It'll be better than if you didn't have the alpha.
Right. So you have to put all those pods into one gang to be scheduled like together, considering the specific constraint. So the constraints have to be constructed like for the specific requirement.
So, question for SIG Apps leads, like what should we do next, given there's a lot of interest in what we're doing in SIG Apps?
You
Let me
have
ask
to keep running basically. The people who are interested in reading it, and I'll definitely have a look at it, can always have a go and read through the cap, comment there, I believe, or the docs that you shared in the agenda. I don't think from our perspective there's anything stopping you from proceeding. I don't know if Janet or Ken have anything to add.
Do you want SIG Apps to be part of the sponsoring or related SIG in the cap?
I would like to, like, at the very minimum, I would love to have an index job have a very small amount of alpha awareness of this resource, so people can see what the end-to-end workflow work is like for one resource, be able to create an index job that automatically manages its gang scheduling thing. And so, is there receptiveness to such a cap in the 135 cycle? Is there possibility of bandwidth? I don't know what your backlog looks like. If the answer is no, then we'll proceed in scheduling, but would love to show end to end if possible.
So I guess that was the question I had, right? Like it's not so much like, yeah, cool. Like you don't need our permission to do this. What do you need from us to be successful? And it sounds like what you need is you want a cap on index job in order to like actually get the feature useful, and you want to try to co-launch them in the same release, right?
That would be the best, so we can say, like, look what we built, and people can understand hands-on what it will do.
I mean, I have zero objection to that a priori. I have to like, since it's alpha, we do have to look at it and make sure that whatever we do is both backward compatible and has an evolution path forward and potentially a back out path if necessary, right? Like you have to be able to opt in and turn it off. But
Feature gating is easy. The hard part is if we say, like, well, we need one more field in job called like auto workload. And then you're like, well, we argue about the name and like, what if we burn this field, whatever. So that's kind of where we got stuck on pod. And I predict that's where we'll get stuck on job if we do it.
and that's the iffy thing. But like,
All right, I'm gonna send a cap and heads up, and we can discuss, I guess.
yeah, I don't have any objections. Janet, do you guys have any objection to it?
No, we're happy to review the cap.
Yeah, and try to find you some cycles to go implement as necessary. It's probably not a huge, like the PR I have in my head is probably not that big. Like it's probably not even a huge level of effort. It's just a matter of like all the testing and everything. And at alpha level, I would expect more work taking it to beta than what we get at the alpha anyway. So
Okay, thanks very much, Leeds.
Any more questions regarding this? If not, we can move on to the next topic. Yato has a proposal of node level pod GC.
Yes,
have-
can I share my screen?
Sure, let me give you access. You should now have access to do that.
Okay. Oh, sorry, I need to allow the assistant. Okay, yeah, it may take time, so can you open my document?
Sure.
Oh, thank you so much. Okay, so yeah, I'm gonna present the proposal about like enhancing pod garbage collection. Currently, in Kube Control Manager, it has terminated pod GC threshold, which is like cluster level threshold. How many terminated pods are allowed in the cluster? But I'm going to extend it to the node level awareness because in some high churn environments, we have some problems like gRPC message size limits or container runtime degradation. So we'd like to introduce a new pod GC. The goal is to like have a node level pod garbage collection and not replacing the existing cluster-wide garbage collection, which is configured with terminated pod GC threshold option. The proposal is to make a new option, which is like terminated pod GC per node multiplier. The actual node threshold will be calculated in. Can you scroll down, please? Yeah. Yeah, the actual node threshold will be calculated the minimum of max pods times multiplier or the cluster-wide terminated pod G threshold. And yeah, we need some API changes in the Kube Control Manager. And the workflow will be, can you scroll down a bit, please? Yeah. The first, the Kube Control Manager calculates the panel threshold and mark them as delete candidates, and then apply the cluster-wide threshold. When it calculates this, it ignores the node level delete candidates, and even if delete the node level delete candidates was removed, but still there are many pods, like more pods than the cluster-wide threshold, then it deletes them too. And there's some considerations about performance, but I think which is okay because pods and nodes are already listed by the current GC implementation. So from API point of view, there's no like API request increase, but the complexity might be a bit increased, but I think it can be ignorable. If it sounds okay, or if there's no concerns about it, I'm going to write a cap about it. So yeah, any questions or concerns?
How are you planning to handle different node sizes with this particular one?
Okay, so can you scroll up
Because
to the
in
design details?
the simplest case, yeah, it's probably sufficient to say, oh, I want to have like something like when I'm at 80% of that, and you can just divide by number of nodes and
Yeah,
give a
so
number. But for varying, when a cluster has a bunch of smaller and bigger and medium size nodes, that math won't work. So that's probably the most complicated case that needs to be covered properly here.
yes, so in the current proposal, I'm going to use node max pods, which can be configured per node, so it can be used, or like we can use. Can you scroll down in the alternatives? The bottom. Yeah, so like we can choose alternative 2. But I guess I want to use this feature as a like safety net, not like perfect protection for clusters. So I want users to have a like more relaxed limits and like used as a like last result. Want users to like use a last it as a last result. Does it answer your question?
I'm just looking through API because we already have information in the node status about available capacity, and that number has a number of pods. I'm trying to figure out how we are calculating that number, but that could be another number that you might want to consider when calculating a node's capacity, because I would assume that should differentiate between nodes. Yeah. But in general, I think it's a reasonable thing. I don't know if Janet or Ken, but I see Eric has his hands. I'll let him speak first.
Is it a goal, or is there already a mechanism to provide fairness across multiple tenants that use the same node? So like if there's a bunch of namespaces and they all could possibly land on the same node, that they have the equal chance of having some amount of pods available to inspect the history?
So like I want to use it as a safety net, not I don't want the users to rely on it because the terminate pod should be controlled by the controllers, but still we should have a protection to protect from the like noisy workloads. So yeah, that's why I'm proposing it. So yeah, I don't think this will be a perfect solution for like every cases, but I don't want I want to protect the like worst case, like node is unresponsible or something like that.
Can I ask a question? What is the resource that you hit the pressure on in this use case?
Yeah, so in the program statement, the biggest concern is the gRPC message size limits.
Okay.
And yeah, this can be fixed by the pagination in CRI API, but it will need collaboration with Containerd in CRI-O. It will take much more time than this proposal. And also content runtime will be affected, like memory usage. If it has a lot of ports, it uses memories per containers.
So on the downside of just upping the GC threshold, right? Because I mean, like if at some point like you're actually exhausting, I guess what ultimately becomes a network resource via the message size, and pagination is something that's difficult to implement. What happens if you just up the GC threshold so that it creates GC, it garbage collects more aggressively? Like, are you running into performance considerations when that happens, or is it just like you don't want to unnecessarily GC pods on nodes where you're not seeing the high pod churn? Like, you want to provide kind of a mixed mode operation across the cluster where on these nodes where, let's say I'm running some CI/CD work and we have a huge amount of pod churn, we'll collect those more aggressively, but on the rest of the nodes in the cluster, which maybe are of a different size or just aren't seeing the same amount of churn because they're labeled differently and we're only scheduling stateful serving or stateless serving workloads over there. We want to leave them alone. Is that what you're trying to achieve?
Yeah, so like as I said, it's like a safety net. So before like node is responsible, Kube Control Manager should manage the number of terminated ports in the node. So the Kube Control Manager should delete more ports than before, and like should use more memories or CPUs. But like as I said, I hope they don't rely on this feature, and also yeah, so yeah, as I said, yeah, I just want to use this as a protection.
Hmm.
Philip?
Can you describe what kind of workloads have you experienced this with?
Yes, so we had experienced some issues in the like Argo CD CI/CD environment in Kubernetes cluster. Let me check.
If it's a cluster that you've specifically dedicated for that purpose, right?
But not dedicated. That's the like just an example.
Okay.
But yeah, if it can be affected, like it can be affected by like any clusters.
So, and did you mitigate it by like increasing the GC threshold or like what? That's what I'm trying to understand. It's like, okay, um, I'm not GCing fast enough. So if it was me, my first step is cool. Let's tell the system to GC faster and see if that solves the problem. Did you try that?
Um, yeah, actually, no, because at the time the node is already unresponsible, and also, yeah, it's too late. If it hits the threshold, mm, mm, it's too late if.
It's too late to mitigate it immediately, but when you come up with the RCA, they
Yeah,
basically
so for example, like there are like multiple nodes and the number of nodes is varied, then no terminated port GC threshold is can't be used as a protection.
it won't work for you. It doesn't collect fast enough.
Yeah, so the current implementation is can be used as a protection.
Where are those terminated pods from? Are they from jobs or are they failed pods?
Yeah, they are from jobs, and yeah, that can be from anything. that creates pod and doesn't manage them.
Because I'm thinking that if it's from job, you can leverage the TTL controller.
Yeah, but if like some other like custom controller creates some pods, then and it doesn't have a like deletion mechanism, then it will affect the cluster.
Yeah, I know we have like this problem in a replica set controller, and in certain conditions there can be a lot of runaway pods. I actually have a PR opened for introducing a backoff into a replica set, which still is under work in progress, but it's like one of ways to solve this if you identify the controllers that are creating so many pods that like introduce some kind of backoff mechanism.
Yeah, I think the questions I would have is like I'm not diametrically opposed to adding like a secondary garbage collection mechanism that works on a per node basis. But I think some of the things that have already been brought up in terms of like setting it as a threshold on controller manager means that you can find some heuristic, I guess, based on node size. Like different nodes of different sizes are going to probably want to set this threshold differently based on the shape of the machine, right? So like I would almost look at it as like a node parameter. Um, but I mean, you could set it as some fractional percentage, right? Like
Yeah.
there's some heuristic you could use to say, this is the global parameter I want to use. It fits heuristically pretty well. And I will like take the amount of utilized resources, particularly those that are uncompressible, these maybe even compressible ones, and then come up with based upon what's allocated, what's being used, and what I've got using this like ratio or this weight, figure out like how much I'll tolerate, and then start collecting. I think that the fiddly bit there is like now you have to think about how it interacts with the rest of the garbage collection mechanism, which acts globally, right? You have two competing mechanisms, and that's not impossible, but you just have to be sure it works well. If we're going to go down that path and introduce the initial complexity, I want to understand kind of the scope of the problem and like how it how it might interact presently with the garbage collection mechanisms we already have, right? Like if you're telling me like, cool, we're having GC problems, so I set the threshold high and that caused cluster instability on the other side, that's like a strong motivator to go do something now because basically clusters are breaking. If it's a minor optimization and if people can be in a relatively good place by just using the existing global mechanism, we might approach it differently, in my opinion. Majek?
I started looking around because when you can mention that this should be a per node, it turns out that we have a deprecated field which was called maximum dead containers, which is currently deprecated in favor of something that is called eviction soft and eviction hard, which allows an operator to define limits per kubelet. So before going further, I would probably advise you to have a look through the kubelet command line options. It seems that there are a couple of configuration options that could potentially solve your problem. Were you able to look through those?
Yes, yeah. Actually, I'm from Signode.
Uh-huh.
Yeah, so I'll take a look. Thank you so much.
I think so this would achieve something different, right? The eviction pressure thresholds are when you start evicting pods to reclaim resources as opposed to starting to reclaim resources from pods that are potentially carbon. This is like can I garbage collect locally earlier in order to get a more uniform distribution of dead pods across the cluster type thing?
Um, mm, the initial concern I have was like conflicting the existing terminated but GC threshold because this is managed in the kube control manager is different from kubelet. So I don't want them to like delete too much pods
Yeah,
more than threshold.
yeah. Yeah. And no, I
Yeah,
get
but yeah, but
you
yeah,
have a
okay,
global control mechanism and you want to ensure that it interacts well with whatever else happens in terms of garbage collection. But I guess I kind of lean toward like if Kublet's able to make more optimal decisions based on local information and knowing what the allocatable resources are versus what's actually under pressure and used, it almost seems like making the decision there would be better. But there would be complex interactions potentially with the global pod GC. I get it.
but yeah, thank you so much. Yeah, I'll include that discussion considerations in the proposal.
So we're at time, and we have still one topic from
I'll
chat.
take quickly 30 seconds and let everyone go. I went through the 135 items that we have. I tried to categorize those elements into 3 groups. The ones that we already know who is working on them, and we're certain that they will be moved forward in 135. We have a few uncertain and need help caps. If you have any opinions about any of those, feel free to let me know, and we can juggle them accordingly and slowly move forward the appropriate enhancement. So that's basically all. All the information is in the agenda with all the necessary links and all that. So hopefully we'll be able to push some of those forward. That's all I wanted to say, basically.
Sounds good. Thanks. All right, I think that's all for today. Thanks everyone for coming. If you have more questions, feel free to ping us or follow up in the future calls.
Thank you so much.
But
See ya.